In this video, we're going to take a look at a problem that incorporates both horizontal motion and vertical motion. And we're not quite there with vectors yet, but this is a real fundamental test of our knowledge so far. So in this situation, we have a block that's on a horizontal surface and there's friction. And remember, friction is a coefficient. Essentially, what it comes down to is that friction, the frictional force itself, is a percentage of weight. So kinetic friction is always less than static friction. The idea being once you break it loose, then it's going to slide along easier than when it was just the rough surfaces are sort of interlocking. So we're going to add sand to this bucket and add enough sand so that it breaks free from friction, and then we'll see what the acceleration looks like afterward. So those are the two parts of the problem. The first is to get it moving. And now that it's moving, find the acceleration. And tension in the string. Okay, so to get it moving, let's see what that looks like. So if we're talking about free body diagrams, we have tension that's trying to pull this and get it moving. And the tension arises from the weight of the bucket and the sand. So we know that friction is sort of a lazy force, that there won't be any friction until we start pulling on it. And then when we pull on it, friction will exactly equal the amount of pull until it just can't hold on any longer and it begins to slide. So the largest possible force of friction is equal to the coefficient of static friction times the normal force. And on a level surface, the normal force is just equal to the weight. In the next week, we're going to have things on the inclines. So this is not going to be true anymore. So just to underline that point, this is always true. And this is true for only horizontal. And assuming there are no other forces acting on it. Okay, so we can get a number then. And the coefficient of static friction is 0.5. And the mass is 8 kilograms. And the value of the gravitational field for the Earth is 9.8 meters per second squared, or newtons per kilogram, 0.5. Okay, 39.2. So then the weight of the sand in the bucket has to equal 39.2, and then it'll start moving. So that means the force of gravity, which is mass, and this is a different mass, so I'll put S here for sand, times gravity has to be equal to 39.2 newtons. So the mass of the sand is going to be 39.2 divided by 9.8. 4 kilograms. Right. Okay, so now once that's 4 kilograms, it's going to start to move. And the tension would simply equal the weight of the bucket, or the frictional force at that moment. So now it's moving. Let's see what happens. It's a two-body problem, so we're going to want to solve the system and we do F net equals MA. And again, so as always, when we take a look at Newton's second law, we're going to put the causes of the motion over on this side and the effect over here. So the cause of the motion is that the weight of the sand, which is 39.2, is making this move, but it's being held back by friction. Now the friction is no longer 39.2, it's going to be slightly less. And that's going to cause both masses to accelerate. So the weight of the sand, we can assume once it started moving, no more sand was added. So then this is going to be 39.2. And now we have 0.4 times 8 times 9.8 is going to be equal to 8 plus 4 times whatever the acceleration is. So that looks pretty good. Very reasonable. This calculator where you can see it. So 39. Well, let's start off. Let's calculate friction first. So now we have 0.4 times 8 times 9.8. Okay, so friction decreases a little bit. It was 39.2, now it's 31.4. So 39.2 minus the answer I just got is 7.84. And then that's equal to 12 times the acceleration. So we can find the acceleration, and that's equal to 0.65. Right. And now what about the tension? So when it starts moving, does the tension go up, go down, stay the same? So that's a good question. All right, well, let's try it then. So let's isolate one of them. Isolate the sand. And so the free body diagram for the sand is going to look like, I'm not going to draw a bucket again, but we have an upward force and a downward force. So the downward force is gravity, of course, and if only gravity was acting on it, it would be in free fall, but the tension holds it back. However, it's still accelerating downward, so we need to take that into account. I'll do this last part in a different color so it stands out a little bit. So F net equals MA. Okay, we have Ft is pulling up and we have gravity pulling down. And then this acceleration is going to be downward. So this block accelerates to the right at 0.65, but this one is accelerating downward. So, and the mass is 4. So negative 4 times 0.65. So the tension is going to equal the weight, which we know is 39.2, minus 2.6. So the tension actually goes down. So 36.6 newtons. Okay, that's a really good example, and It'll be really useful for this week's quiz too.